Hello there, I'm K-Ball, and welcome to Human Skills, where I interview tech industry leaders about all the non-technical skills that go into success in the tech industry. There aren't many people who have written a web framework that changes the way people think about web development and gets used by millions of people. And there are even fewer who go on to try and do it again. But Miško Hevery has. Miško invented AngularJS during his time at Google, and now has invented Qwik to try and fix some of the fundamental shortcomings he sees in the current generation of frameworks. In this interview, Miško and I talk about how to create organizational change, the importance of vision and passion in creating great things, how to change someone's view of the world, and much more. Please enjoy this interview with Miško Hevery. I am joined by the inventor of the Angular framework, the now CTO of Builder.io, and inventing yet another web framework for us, the one, the only, Miško Hevery. Miško, welcome.
Thank you for having me. That was quite the introduction. I'm not sure I deserve all those credits, but I'll go with it.
No, I mean, you're one of the people in the web world that I look up to, and I'm like, wow, that guy. So I'm super excited to get to talk to you about this and learn a little bit more about kind of what has gone into the publicly visible success. So maybe can we start a little bit, and you could take us through your story of your career today, and I'm looking at this from the outside being like, wow, that looks cool. But I'm sure it wasn't, there are hairy parts, there are good parts, there are bad parts. But, take us through and maybe some of the challenges that you faced along the way.
Absolutely. First, let me do a little detour here. You said like, oh, that guy. A lot of people goes like, oh, that guy. So it goes both ways. But let's jump into the history of how we got here. Yeah, so it's kind of interesting. I do software, but that's not what I studied. I actually studied hardware. I know hardware and software are kind of similar, so it's not that far apart. But actually, my degree is Master's in Computer Engineering, which means, all things hardware related. And specifically, I actually did a lot of stuff with chip design and silicon layout. So, I like to joke that I'm like the only JavaScript engineer who knows how the transistor works. I don't know if it's true. I'm sure there's other software engineers who know that. But
I will say that I started in physics. So,
there we go.
We all make our way here in different ways.
There we go. So, I started with hardware. And actually, I started coding or playing with computers at a pretty young age. I think I was like 13 when my dad bought a computer. And, back in the day, a game was on a tape. You had to play the tape back to the computer on the tape player. People don't even know what tape player is these days. Forget the idea of playing a game on a tape player. And it was, I think the whole computer had 64 kilobytes. It was split between the video and ROM and the operating system and the actual free memory for the game to play with. So it was really only like 40 kilobytes or something. And those 40 kilobytes took 5 minutes. So it's a long way back. But anyway, so I started with computers, and I knew I wanted to do something with computer technology. I went through, high school, and then when I was kind of graduating, I was kind of, the interesting thing was that I went to a guidance counselors in high school, and I said, I want to do something with computers. And they had no idea what I was talking about, right? They're like, oh, so you want to do data entry? And I'm like, that doesn't sound right. And I would go to library and I would look up data entry, and I'm like, no, I don't want to type stuff into the computer. I want to program these things. So I kind of went and I actually applied to Carnegie Mellon saying like, hey, I want to do, and I was confused about the topic. So I thought I wanted to do software, but I thought it was computer engineering. And so I applied as a computer engineering, and Carnegie Mellon sent me a nice rejection letter saying like, there's so many people applying to computer engineering. We don't have space there for you, but maybe you want to do computer software, do that instead. And I was like, no, I want to do engineering. So I actually declined them, and I went to a school up in Rochester, New York. And interesting thing about that school is they had a fab on premise.
Oh, neat.
So they actually were able to manufacture the silicon and go through all the steps, etc. And so as a result, the computer engineering department there was very focused on chip design. And yeah, super interesting stuff. We can, delve into it, but that's not probably what you want to talk about.
Whole
And
nother
so,
podcast.
whole lot of podcasts. Yes, whole lot of podcasts. Yeah, so I kind of finished with that, and I remember my final project, we actually had to lay out a chip, so I laid up a chip, and I printed it on a large format thing, and I hung it over my bed. My then girlfriend, now my wife, was very confused as to what it is, and she didn't like that particular piece of art. But yeah, that's kind of what I did. And when I graduated, I went actually to work for an embedded software company. So I worked on like printer software. I don't mean the drivers for the printer that goes on a computer. I mean the actual software that runs in the printer.
The firmware.
The firmware itself, yeah. And that was kind of interesting. So I did that for a while, and then the company decided that like, hey, this internet is a thing. We should probably do something in this space. So instead of doing embedded systems, let's see if we can do something with the internet. And so they kind of took their people and kind of re-educated them on how to do databases and how to, do e-commerce or whatever was kind of cool thing to do back in the day. And so that's how I got into databases and server technology. From there, I really wanted to come to California. See, when I was interning in Intel in like '96, I know I'm dating myself. When I was interning in Intel, I was in Folsom, up in Central Valley by Sacramento, and I really liked California. I specifically liked like the fact that you could go hiking. Tahoe was nearby. You could do some amazing, like mind-blowing hikes in Tahoe. Like it's hard to kind of explain unless you've been there.
Absolutely.
And so I knew I wanted to come to California. So when I graduated, I kind of made it for me like a goal. Like somehow I'm going to end up in California. So the company I work for, that decided that internet was a thing, they kind of sent me to Phoenix, Arizona. And I was like, Phoenix, closer to California than Rochester, New York? I'm going. So for a while, I was actually working at Intel in Phoenix, Arizona. And then I finally ended up in Silicon Valley in early 2000. And I've been here ever since. I worked for a bunch of startups that nobody has ever heard of because they wouldn't go anywhere. I worked for Adobe. Then I went to work for Sun Microsystems, which people probably haven't heard from around these days anyways.
I interned there.
Oh, did you? Okay, perfect. Yes.
Also dating myself, I guess.
And then finally I ended up at Google, and I was in Google for a pretty long time. I think 16 years. Which was a long, long time. And, after 16 years, I really wanted to just try something new. Google's a wonderful company. I have nothing bad to say. I totally enjoyed my time, which is, that's why I stayed there for so long. But, after a while, you just kind of start to wonder, like, hey, like, what else is out there? Let's kind of go and explore. And so about 2 years ago, I said, okay, let's go and explore. And, I looked into startup space a little bit, and I found Builder.io, and Builder.io did stuff that was pretty innovative, and I thought like, hey, like this sounds interesting. I could see myself here, and so I ended up at Builder.io as a CTO. So that's kind of the overview. I'm sure you want to drill down to different places.
Yeah, well, so one of the things that immediately strikes me is, as you're moving from hardware into embedded software, into internet software and web software, there's certainly a set of technical skills that you had to learn along the way. But I'm curious to hear a little bit about like kind of the non-technical things that stayed consistent as you moved throughout that.
Yeah, actually, if anything, I think you grow in the non-technical things, right? When you start your work initially, you think it's all about like knowing stuff. And so you pride yourself on that, and you like learn things, and you impress your coworkers just by how much you know or how much you can output, etc. And I think it comes later when you kind of realize that like, hey, there's more to this thing than just knowing things. Specifically, the problem is that there's only so much you can achieve, right? Like no matter how amazing you are, no matter how talented, how much throughput you do, etc. At the end of the day, a team, of 10 people will outmaneuver you because, well, there's just more of them, right? And team of 10 is not even that big. You could have larger and larger teams. And so you realize that the importance of kind of the team. And I think it's kind of reflected in many companies' ladders, right? The internal systems for kind of grading engineers. And in Google, the way it was is they had levels all the way, I don't know, the levels are weird at every company, but Google's levels went all the way to L5 for an individual contributor. In other words, as you get better at producing stuff, as you get better at your own skills, as you go become more and more independent, we have different levels by which we can kind of grade you. But at level 5, it was kind of the end of the story in the sense that, like, if you wanted to go higher, it was no longer about making yourself better. It was about making the people around you better, right? So the L5 to L6 transition, and I'm sure different companies have different labels for these things, but that transition was very kind of stark, right? Because you go from like, how do I internally, it's about me, to externally to like, well, how do I make people around me more productive? How do I make them better? How do I make them grow? How do I, set up the environment in a way that they can do their thing in the best possible way? And the interesting thing about that is that a lot of people have trouble making that transition, right? It's not a easy thing to do because it's a completely different skill set. And so Google actually had a point that's saying like, look, we expect all of our engineers to eventually reach L5, right? Like if you're not growing and if you cannot get to L5, then we need to kind of have a conversation because like, eventually you should get there, right? But there was no expectation to grow past L5 because that's a different step. That's a different thing, right? To go where you're now focusing on not about you, but about the team.
So what would you say, looking at that transition? Well, one, what was hard for you when you first made that transition? And what have you seen other people struggle with or that has kept them from being able to go past that L5 individual, purely about my personal productivity level?
Yeah, there's definitely something that I think I've seen a lot of people struggle with, especially myself. I mean, I'm not in any way special in this thing or like, exempt from this particular thing. And that is that when you are an individual contributor, when you do work, it is easy at the end of the day to kind of look at the day and say, what did I achieve? And you can point to, code you've written, bugs you fixed, infrastructure you moved around, something tangible where you're like, yes, I have made some progress today. The hard thing about teams is that the impulse, the thing that you apply, right, and the effect, the thing that comes out on the other end, are really, really separated. Sometimes by months, maybe even years, right? And so it is kind of driving blind where you have to have faith that you're like, okay, the thing I'm doing, I think eventually will have the right outcome. So the faith is kind of important in it. But there's a second problem, which is you don't get instant satisfaction. And that's super hard. And at least for me, and I'm sure others kind of fall into this category as well, it becomes, you feel useless. You feel like, you look at your day and I'm like, what did I do? What did I achieve? What am I going to kind of put on my, check mark to?
Yep.
And there isn't really anything. And it's frustrating. And I struggle with this a lot. And I continue to struggle with this to this day. So I think this is kind of the biggest problem with this kind of the transition.
Yeah, no, I feel that very deeply. So I'm curious, what tactics have you found for yourself to help get past that sort of feeling of not having the feedback, not having the satisfaction of, I wrote the code and the test turned from red to green, right?
Yeah, that's a hard question. I don't know if I found it. There's a couple of tricks I do, but I don't think I have like a silver bullet that works. First of all, I find it super useful to just write down everything you're doing, right? Even if you're doing silly thing like, I have drained my inbox, I write it down. Like, I know this is not something to brag about, but I write it down. I drained my inbox. I've drained my Slack. I replied to the people on Twitter. I have, and the thing is, you look back through the day, it's like, it's not like you were not busy. That was stuff you did. But any one of those is like, like, yeah, you drained your inbox. Good job. But somehow I find that just by writing it down, it's easier to find the gems in there, because every once in a while you do something that's like, yes, that thing really mattered. And so, at the time when you did it, it might be difficult to kind of know what the gem is. But if you just write everything down and you look back throughout the day or maybe through the last week, it's easier to reflect and be like, oh yeah, that thing over there, that email that I sent to my coworker that made them understood something, or, I apologized, or whatever you have, right? That thing had an effect that changed things for the better. And maybe you can see it in the, week or whatever, but that effect is like when you can easier to connect and it makes it better. Yes, it's not a, silver bullet thing, if that's what you're looking for. I don't have that, but.
I mean, I'm not sure there is a silver bullet thing for this, but we're all struggling with this. As I said, I feel it very, very deeply myself. So interested to hear. I am curious because one of the things that, looking at you from the outside and your career, like, you are the name behind Angular, which, once again, like, as you said, some people are going to curse you for that, but also pushed the web and JavaScript frameworks dramatically forward, regardless of what people think of the outcome, right? Whether or not you like Angular today, it was the first pushing things towards the direction that became React and a bunch of other things. So you look at that and you think, gosh, Miško is brilliant. He must be incredibly productive and good at making something happen because your name is on it. Is that the story? Or what I'm hearing from you now is all about team and push and interpersonal. So I'd love to hear a little bit of the behind the scenes of, like, what were the things that went into that?
So, I think luck favors the prepared, I think the expression is, right? Something like that. So there's certainly a huge section of a part of luck in there. So originally Angular wasn't supposed to be a framework. The thing I wanted to solve was a different problem, which is that I build web apps at Google, and all the web apps were the same. Like, how do I get data from the database to the user and from the user back to the database? Right? Like, that's what a web app is, right? And so after a while, you kind of get tired of it and you say to yourself, like, well, can I automate this somehow? And my original idea was like, well, can I make it so that non-developers could do many of these things, right? And this is why the original idea was to kind of extend the HTML vocabulary. But it turns out that at the time, there were no other really frameworks available. I mean, the closest thing to a framework was Backbone. And, if you look at the Backbone, it was kind of like small part of, like, it kind of had data management, but not really UI. Like, it was kind of heading the right direction, but it didn't really go far enough, right? Whereas Angular had a different goal, which was that, like, look, non-developers need to be able to do many of these things. And so you need to look at the cohesive end-to-end problem and solve that. Now, it turns out that non-developers have a separate problem, which is that they don't know how to think like a developer, right? Like, there's a way you have to think to yourself, which is like, oh, I have an invoice. Oh, no. Actually, there's an invoice and it has line items, and then line items have a one-to-many relationship, and then I have to do a iteration of them and do a sum, right, to get the invoice. Non-developers don't think that way. They just like, I have an invoice, I want to store it, right? Like, hey, but you got to break the problem down. And so it turns out non-developers had trouble with kind of the original Angular kind of vision, because it turns out the issue isn't necessarily writing the code, it's to think in the particular way that is conducive to code. But nevertheless, Angular did an awesome job of simplifying the DX. It was kind of unintentional, but it nevertheless did that. And so I think the reason why it shot in popularity is both because there was a void, there's nothing else in that space, and also because it tried really, really hard to make the DX as simple as possible. And it turns out that if you're a developer, even though you can do complicated DX, simple DX is nicer. So you like that, right? So you kind of go with it. So I think this is kind of where Angular kind of came from. From day one, there was a team of people on Angular. I guess in that sense, I was lucky. Like, I can certainly take credit for having the original idea, the original vision, the original implementation, the push towards it, because there's got to be a certain level of stubbornness you have to have in this particular place. But very quickly, other people are involved and they help you with many things, and very quickly it turns into like a discussion and group discussions of different ideas and so on and so forth.
Let's talk a little bit about that stubbornness and the push.
Yeah.
I saw at some point recently you were tweeting about the importance of having a vision holder and passion in making something.
Yeah.
So I'm curious to hear a little bit more about your perspective on that.
I don't remember the exact wording of the tweet, but I said something along the lines of like, great things are not created by organizations. They're always created by individuals. And what I did not mean is that somehow I'm special. That's not what I meant to say, although some people interpret it that way. What I meant to say is that you need to have a person who's passionate and who pushes this particular idea, right? It doesn't mean that person does everything. Like, certainly the team is important, right? But you need to have a person at the very, very beginning who has, I hate to use the word vision, but I can't think of a better word, who has this thing of like, I can imagine what the outcome of this thing could be. I know where we are today and I know how we struggle, and I can imagine this other world where we can be. And the thing I notice with people is, and I'm guilty of this just as everybody else. I'm not saying I'm above this, but one thing I kind of notice a lot with people is that when you present a new idea, it is by far so much easier to criticize it and tell you why that idea isn't going to work, rather than to say, how could it work? That's super hard. That requires a, complex problem solving, right? How could it work means like, this is where I want to be. This is where I am. There's a chasm between where I am and where I want to be. And I got to figure out how to build a bridge, right? It's easy to basically sit there on the side of the chasm and tell you like, these are all the reasons why you can't build a bridge. The material isn't strong enough, the whatever. Like, there's gazillion reasons you can come up with. The hard part is to kind of say, okay, yeah, that's a valid reason. Like, you're not wrong on this. But like, what can we do? What particular constraint can we move or look at it differently so that it becomes possible? I think one of the things people do is, we all do this, right? Like, again, I'm not above this stuff.
Well, and this is like stereotypical engineer. I want to do this thing. No, you can't. It's
yes.
right? So I really want to hear like how you do that mind shift. Once again, like, are there tactics that you can do to help force yourself to do it?
Yeah. So human mind, right? Like, we can only keep so many ideas in our head at once, right? Like, we have a lot of space for lots of different ideas, but the working memory is pretty small. And so what is it? People say you can only have 7 digits of phone numbers in your head or something like that, right? I think the actual working memory of the number of things you can have in your head, I would call them symbols that you can have in your head, is very, very small. Certainly under 20. I don't know what the number is. I don't know if it's 7 or 10 or whatever, but it's small. It's like counting on your fingers kind of small, right?
Yeah, I tend to default to 3. Like, you can have 3 chunks.
Yeah. So I'm going to give it some, I'm not, I basically.
Maybe you could probably hold more than I can.
No.
I'm a very simple man. 3 chunks. There we go.
I am horrible at holding multiple things in my head. I can do like one thing at a time. That's all I can do. But, even if you do one thing at a time, there are multiple things that you have in your head. So I'm going to basically say there's like 20 different symbols that you can kind of juggle in your head, right? And so the problem is the ideas we work with are way, way, way more complicated than those 20 symbols. And notice I'm calling them symbols because what it is that you take these ideas and you give them labels, right? You give them names and you give them these symbols. Even if they don't have a name in your head, like, what they represent. And so then your brain gets to kind of symbolically manipulate these 20 things. And so the hard part is kind coming up with the correct set of symbols in your head so that you can kind of deal with this particular problem. Some people call it the mental model, right? Like having the right set of things in your head so that you can kind of work with this. And the way you name these things and the way you break it up and the way you like assign meaning to the symbols matters hugely. And what I find is that whenever you come to an impasse where you're like trying to solve something and it's like it can't be done, right? It is usually you're correct in the sense that as you define those symbols, there is no solution. But the thing is, you probably made an assumption in one of those symbols, or like you over-defined or something, that you could move these things around. And if only you could like move these things around, the solution would become obvious. So whenever like, we have discussions on a team, and whenever we come to an impasse in the sense where like, we have all these constraints, and no matter what we do, like these constraints are not working out, like this isn't going to work. The solution usually is to kind of say like recognize this is the situation, and then kind of say like, okay, let's back up a second. What set of assumptions do we have, and which of those assumptions are things that we absolutely positively have to have, you cannot give up, and which of those maybe you could give up or are not actually important or something like that, right? And so you kind of do an inventory. And a lot of times I find that when you do that kind of inventory, you end up with a different set of symbols, for lack of a better name. And then the solution kind of becomes obvious. Like, oh, if you remove this constraint, of course you can now do this, right?
Yes. Well, and what I love about this too is, in my experience at least, this shows up even more when you're bridging across disciplines.
Yeah.
Because each discipline will have its own set of assumptions and its own language. And so
Yes.
someone will come to you from product or marketing or somewhere else and say, can we do this thing, and describe it in a way that to you communicates a set of assumptions that to them are completely unimportant and perhaps not even in their mindset.
Yeah, that is a very good point. Like whenever you have different groups that have, when you have a group that has a shared history, you end up with shared language. The moment you have a newcomer coming in, or if you're just talking to a different group, one of the hardest things to do is to bridge the language between these two groups. Like forget even solving anything. Before you even get there, like the first step is to just like, are the words you're using the same words as I am using? I know they may seem like they are, but oh my gosh, they're not. There's.
You keep using this word. Does it mean what I think it means?
Oh yeah, and a lot of times it's even worse, right? Like it looks like it is the same meaning, but then you'd go into the details and you realize, oh, actually, it's not. Like, there is the spoken, I'm going to define something as this way. And then there's the unspoken of like, the implications of this meaning are this. And even if you find that two people share the same meaning for a word, the implications they share are usually not the same. And so, yeah, I mean, the only way I found this is to just spend a lot of time chit-chatting and comparing notes and drilling down to like is this word, like is this what you mean by this word? Like you keep using this word, like to me it means this and it has these implications. Does that like what it means to you? Oh, it doesn't. Like you have different implications. Tell me more. Like why is it different? And usually getting the common vocabulary is by far the hardest. Once you have the common vocabulary, the solutions are usually obvious. This is the thing that I find so amusing, which is that once you understand the problem, the solution is literally staring you in the face. It's like, yeah, of course you do it that way. Like, how else would you do it, right? But like, just understanding the problem is so hellishly difficult. Like, that's the hard part.
Well, and honestly, coming back to the career ladder concept, I feel like some of what that progression is moving from working entirely in the solution space after the problem is well defined, and moving up to poorer and poorer defined problems,
Yes.
where the majority of the work is figuring out what it is you need to, what you're even trying to solve.
Yes, absolutely. Yeah, I mean, vast number of people, right? Vast number of engineers, you give them a well-defined problem, or at least a box to kind of live in, right? As you go higher and higher, you really have to like throw away the boxes and be like, hey, what exactly do we need to solve here? Like what matters and what does not,
Yeah. So for someone trying to make that transition, Any advice for them in terms of how they should learn that process? Now, one of the things you just said was, lots of talking, lots of double checking your assumptions. But what else goes into moving from problem solving to problem defining?
I don't know. Maybe watch your podcast to kind of. I don't know. Like, this is a super hard problem because, like, I don't think there is a well-defined path. Like, everybody else has their own unique Brownian motion through this thing, and they slowly discover and learn and find out what these things are. And I think a lot of times we oftentimes discover the same exact thing. Like, me and you discover the same thing, except I'm looking at it from, my point of view, and you're looking at it from your point of view, and we're not realizing we're actually looking at the same object. Like, both of us, like, I got a tail of the elephant. I'm like, and you're like, I got the tusks of an elephant. Clearly different objects. Like, no, actually it's the same thing. It's just like you're looking at it from the other end. I think a lot of it is that. And so the reason why, communication and chatting with people, etc., matters is because this is where you realize, like, oh, that's this elephant. Like, me and you call it a different thing. We discovered it in a different way, but it's the same thing.
Yes, I love that. Okay. Stepping back to another topic and something I'd love to dig in with you. One of the things I saw on your LinkedIn profile when I was preparing for this conversation was that you were a big part of changing the culture at Google towards a test-driven development culture.
Yeah.
How do you think about culture change? How do you approach that as an individual? How does that happen?
Oh my gosh, it is so hard because what I find interesting with people is that whenever you give them feedback, it's the same thing for organizations. Organizations is a group of people, right? Whenever you give people feedback, they'll tell you, no, you're wrong. Right? But the interesting thing
Even if they don't say that out loud, they're thinking it, right?
They're thinking it, and usually they act or tell you straight out why your feedback is incorrect or whatever, right? The thing that's interesting, though, is that even if they are the most vicious opponent of what you just gave them, it still changes their behavior. Right? So even if they don't agree with you, even if they told you you're wrong or whatever, you observe their behavior like, a few weeks later and you go like, there is a change. Like, even though they didn't agree, they actually are behaving differently. Right? So the reason why I think why organizational change is hard is because you try to do anything and you are met with a huge amount of, I don't want to say negativity, but like friction, right? Pushback,
Yeah,
right?
friction.
Pushback is a good word for this, right? You met with a huge amount of pushback, and so you assume that clearly this isn't having any effect whatsoever, even though it has. So I think changing organizations in some ways is the same thing as what we talked about earlier. Now I can't remember. That like you don't. The doing work, right? Like you look back on your day and you're like, I feel like I've not done anything, right? It's the same thing with organization. Like you feel like you did all these conversations and nothing, and then the reward is way longer in the future. But changing organization is also hard for other reasons. Like I think the best way to change is not necessarily to tell somebody like, please change X, although that has a place in it as well, but to also have them observe different way of doing it, right? A lot of times, a lot of reasons why when you say like, oh, you should do something differently, the reason why you get pushback is because people can't imagine doing it any other way. Like to them,
it comes back to the vision question.
Yeah, to them, like
right?
They are doing things in the most efficient possible way they can think of, right? By definition, right? You're doing it in the most efficient way you can think of. Like, you're not doing it in the dumb way as far as you're concerned. Like, given all the knowledge you have and given all the insights you have and given all the learnings, et cetera, you are doing it what you consider to be the most efficient, best way, right? The thing is, there might be other ways that are not necessarily obvious. And so I think the best way to kind of do that is to work on the same problem together, which is sometimes called pair programming, right? Sometimes it's called co-authoring. or I'm sure there's other ways you can do, but like by doing things together, what happens is you get to see other ways of doing it. Like you assume that it's always done this particular way, and then you see a different way and you go like, what? That works? I was born in Slovakia. And in Slovakia, the way you would open a banana when I was a kid is you would bite off the top part where the flower is, the black part, not the thing that's connected to the banana plant, but the top things. I think is where the flower is, right? You would bite that off and then you would peel it down. And then I came to the US and people would open the banana by breaking off the stem. And I was like, what? There's a different way to open a banana? Like, my mind was blown. I was like, what?
My kids will do it by grabbing the stem and just like flicking the banana.
Right.
It's wild, but it works.
Whatever works for you, right? So my point is, the best way to kind of affect change is to show people a different way of doing it. So when we were doing, trying to get people to do testing, we did talks and say like, this is what you should do in terms of talk, but those never really work. I mean, all they ended up with was a bunch of like snarky comments saying like why their project is different and why it would never work on their project and whatever, right? But what did work is just like, hey, let's sit together and write a test together. And then in the process of writing, you would run into all kinds of issues. And the other person would be like, see, there's an issue, like clearly you can't solve it. And then you'd be like, well, actually, I've seen this before and you can solve it by, whatever, right? And then you do some Rubik's Cube maneuver and they go like, what? And you continue. But the thing is, you didn't really learn that Rubik's Cube maneuver on yourself. Like you got it from somebody else, right? Like you learned it from some other person. Like I think back in the day when you wanted to become a blacksmith, right? You would become an apprentice to a blacksmith, which for the most part really meant that like you were the helping hand and the person who was the blacksmith would tell you like, touch me this, do that, whatever, right? But eventually you would observe enough stuff where you'd be like, oh, I think I could do this, right? And I kind of understand what it is. Humans are really, really good at generalizing. Like if you give us a whole bunch of examples of things, people are so good at like, oh, the generalization is whatever. But the opposite is not true. If I give you a generalization and say, like, apply this generalization to practical purpose, nobody knows what to do. We just don't know how to apply this generalization into actual thing. A generalization or like wisdom or whatever is a thing we have gained by doing multiple different things and then be like, oh, this thing and that thing is like the same exact thing. Oh, I get it. Like it generalizes into this, higher level concept. But if you explain the higher level concept to somebody, they're just like a blank stare and they're like, I don't get it, what you're talking about. What's all the fuss about? Like, how do I apply it? Why are you even telling me this? This is useless. So I find this interesting that like you can't really teach people generalizations in the classical sense of teaching them. You have to show them a bunch of examples and then you have to go to them and be like, so given those examples, like what can you generalize? And that they're good at.
That's really interesting because I feel like that's the opposite of the way we feel like we should approach it.
Yeah, absolutely. Like when we do teaching, a lot of times we start with the generalization instead of like and I'm guilty of this too. Like again, I'm not above this stuff, right? We start with these generalized concepts, and then of course our students like their eyes glaze over, like I don't understand, right? Whereas you should really do it from the other, it's giving somebody a bunch of examples and then ask them to generalize for you.
That's interesting. So that kind of ties into another topic I wanted to ask you about, which is giving talks and presentations. You highlighted that they were not super effective in terms of culture change within Google. I do see you are still doing a lot of talks about Qwik and presentations and other things. So I'm curious, when are they effective? What have you found to make them effective? And what have you found to help you make them happen?
It's not that they're not effective. I think they certainly are. I think you need to do all of those things. You need to have presentations that kind of show like, hey, there is a different way of doing it. Then also have one-on-one experience saying, hey, let's do it. And I think all of those things matter. When it comes to conferences, there's really just two things: workshops and presentations, right? There's really nothing else. Certainly, workshops are more effective, but they're a lot bigger time investment rather than a presentation. I think the point of a presentation is to kind of show people that, hey, there are other ways of doing it. It's really up to you to put the legwork in and figuring it out, right? It's really a marketing thing, right? Like, go and market to engineers by showing them cool stuff. And so hopefully some percentage of those engineers says, that's interesting. That kind of breaks a certain set of assumptions, right? This is kind of what you want to do. You want to get the engineer to go like, wait a minute, this is not congruent with my set of assumptions about the world, right? I bet you they're wrong. Let me go prove them, right? And in the process of proving you wrong, they learn something. Actually, I have a story for you. I'm sorry, this is going to be a tangent, but I have
phenomenal.
I have a story for you. Okay, I don't know how old I was. I was in high school, so whatever that age is, 15, 16, something like that, right? And I'm sitting in the math class, and I had this teacher, I guess professor, I don't know, I guess they call them professors in high school, they just call them teachers. I had this teacher of math, and he was really, really good. I loved him. He was awesome. I think Mr. Rudnick was his name. Anyways, so Mr. Rudnick walks in one day and says, this is a cone. And I'm like, yeah, I got it. This is a cone. And he says, if you take a cone and you slice it under an angle, you get an ellipse. And I'm like, no, you don't. That can't possibly be right. And so I would argue with him for like a good part of the classroom. And he was very polite. And, at some point he said, Miško, I'm happy to continue this conversation, but the class has to go on. So why don't you come after class and, we can discuss this further. And, so I in my mind, I did all of the reasoning why this can't possibly be true. And then I also convinced myself that if you cut the cone in this very sharp angle, it would really exaggerate the problem. Okay, so what I did is I went to home economics class, and you could make clay models over there. And so they had the turning table, where you can spin it for like pottery. So I made a cone in the pottery class, and I took one of those strings and I cut it in the angle that I thought would exaggerate the problem. And guess what? It was a freaking ellipse. And so I took the clay model and I went over to Mr. Rudnick and I gave it to him. And I was like, you know what? You win.
Oh, that's great.
And so then I graduated high school. I went to college. And at some point in the future, I came back to the school just to kind of say hi and to visit Mr. Rudnick. He was at that point a principal of the school. So he graduated from being a teacher to being a principal. And so I came to him. I'm like, hey, how's it going? And guess what was sitting on his table as a paperweight?
That's amazing.
Right? So
that's amazing.
So that's kind of what you're trying to do with a presentation, right? You're trying to give somebody a moment where they go like, you are wrong. I'm going to prove you're wrong, right? And then they can do whatever. And then they realize that actually, it's new learnings that are waiting for you over there.
In some ways, to tie this back to what we were talking about earlier, you're trying to make them take their 20 symbols, whatever that they have floating in their head, and say, there's a disconnect. I have to, through some way, get them to actually challenge those assumptions and say, where is this disconnect coming from? What is the assumption that I have that this does not match? And how can I prove that either my assumption is right or I need to change my...
Yeah, so I think you're hitting it on the head here. I think that if me and you share common definitions on those 20 symbols, we are extremely likely to come up with the same set of conclusions, right? The problem is that we don't share those set of assumptions, right? I'm trying to convince you something and you don't understand what I'm trying to convince you. Clearly you're an idiot. Like, no, that's not how this works, right? The problem is me and you have different set of assumptions. And it's hard to say whether I'm right or you're right. Like, either one could be, right? But the point is The reason we're not agreeing is because the set of assumptions are off, right? And so the thing to figure out is which set of assumptions are wrong. And it may very well be that I made a mistake, right? Versus just assuming that the mistake is with the other person, right? And so like it's this exploration of like, okay, so what are the definitions? What do you mean by this? No. And then hopefully you discover, it's a kind of form of debugging, right? You go through this and you kind of figure out like, what is the difference over here so that we can figure out why the computation doesn't end up in the same way.
Yeah. But in a talk, you're not trying to do all of that.
No, in a talk...
You're just trying to lay out the challenge.
In a talk, you're trying to lay out the challenge, but sometimes you also try to essentially define new symbols, right? And you say like, hey, let's make up new concepts here. And then it's super hard to kind of explain because, again, the only thing you can do in a talk is to do generalizations, right? And so this is the hard part. What you really want is to give people a bunch of examples and they generalize themselves in order to get that symbol. So it's hard and it's a constant struggle. But that's kind of what you're trying to do in a talk, yeah.
So how do you approach that? How do you, when you're sitting down, you're like, I'm going to do a talk on a subject.
Yeah.
What do you use to break it down and figure out what goes in?
First of all, I'm not very good at it because I'm struggling. I think the common mistake people make is and I'm guilty of this all the time, is they over-assume what the reader or the recipient understands, right? There's so many things that are just obvious to yourself that aren't obvious to the other person. And so because of that, you end up making the presentation at much, much higher level than it should be. And of course, in the process, you lose a lot of people. Whereas if you make the presentation at the lower level, you feel like I'm almost insulting the audience because this is so low level, right? But you forget that actually the thing, there's nothing intrinsically complicated or simple. What's intrinsically different is that you have a different set of assumptions, right? Like if you think about it, you can talk to a child and the act of talking is immensely complicated, right? But yet the child handles it just fine because that's one of the things that they mastered, right? And so the trick is kind of figuring out, where your audience is and kind of meet them there. And it's hard. It's super, super hard because the natural tendency for us is the curse of knowledge is we assume that if something is obvious, we assume that it's also obvious for the other person, which, probably isn't. And so, I don't want to say dumb it down because that seems derogatory, but you do need to simplify it in a way that meets the audience. And you do need to understand the fact that like you've been living in this problem space for months, whereas the audience has not. And so things that are absolutely obvious and need no discussion for you actually are brand new concepts that need to be explained to the audience. So this impedance mismatch, right? It's kind of, some people call it impedance mismatch, is kind of the complicated, hard thing to get. And I see that is by far the hardest thing to master, to kind of put yourself into like, what does the other person, what is the mental model of the other person? What symbols they have, what symbols they don't have? How do I kind of work with that? Then that's the hard part.
Yeah, well, and that's going to vary by audience. Right?
Yes.
So you mentioned giving a conference or a talk at a conference, and there I think you can make one set of assumptions about where people are coming from, but you might also give a presentation to a stakeholder or to a potential customer. Yeah.
So I think another way to we're talking about like how you kind of share or teach or influence, right? I think one good trick that I've seen, actually, Ryan Carniato. I don't know if you know who he is. He's the creator of SolidJS. You should talk to him. Anyways, he does a good presentation where he has a separate framework and he builds a component that is very similar to a React component, right? And what that does is it makes the audience be like, to come along. And they're like, yeah, I understand, this method is the same as this method in React, and they have analogs between the two sides. And so they're following along. And then what he does is he takes a method and moves it outside of the function. And that's a no-no in React land. Like, you can't do that. Like, that's clearly written in stone. Like, no, one shall not do this, right? But in his world, it's allowed. And so he moves it out, and the system not only still works, but it has the expected change of behavior. Because it was moved out, the two components now get to share their state rather than two components having separate state, right? And that creates a kind of a moment of like, what the fuck just happened? Oh, sorry, sorry for cursing on your podcast. The cries of WTF moment, right? Of like, wait a minute, you just did something that clearly is not allowed, but you did it and it actually works. And so I think that's the moment you are going for when you're presenting, because that's the moment where you like shake somebody's land in the world and be like, hey, there's a different way to open a banana, right? Because you like invalidate the set of assumptions that they clearly thought that they had, and there was nothing to kind of discuss. Like, of course it's always done this way. How else would you do it? And then you come along and be like, well, actually, no. And then that sudden jerk is the thing that like, breaks their mental model. And so the natural thing is to kind of like start questioning and moving things around and kind of like reconciling what the hell just happened, right? And I think if you can do that, if you can pull this off, then I think it makes for a very powerful presentation.
I love that. And I love the description of it as a sudden jerk, because if you start with something totally outside your experience, it's not going to work.
Yeah, it's not. You
have to start from a place that they feel like they understand.
That's right.
It feels comfortable. You're bringing them along, and then yank them into a new reality.
Yes. And, if you, the longer you can kind of string them along, the more kind of invested, etc. They are. And then the more like eye-opening that sudden transition is going to be. And more you kind of can then like say like, look, there's a different way of looking at this thing. You don't have to look at it in this particular way.
I love that. Well, and I think coming back to then some of the times you might do a presentation, if you're trying to evangelize something, you're trying to create culture change, what you've created for yourself there is an opportunity. Mm-hmm. Now they're ready to reassess. Okay, what do you do with that now?
Oh, yeah. Hopefully present. I think the hardest problem is to explaining the problem, right? We kind of talked about it earlier, right? So the thing you're trying to do to the audience is not tell them like how amazing your solution is, but kind of explain the problem you're solving, right? So, with Qwik, which is the new framework that we have, the problem we're solving is too much JavaScript. The hard part is that most people are kind of at the beginning of their journey in terms of developing web applications. And so they haven't lived the suffering of, having this humongous application that is slow and your management says, make it faster, but you're like, I don't know how to make it faster. It's not like you feel kind of stuck, right? Because you don't have that experience, it's really difficult to talk about, what problem Qwik is solving, right? And so we find that like people who had this experience, who are experienced, usually more experienced senior developers, they look at it, they go like, yes, I wish I had that on project X, Y, and Z, right? Whereas the newers are like, oh, so it's just different syntax. Okay, that's cute. And they, they don't kind of get it. So explaining the problem is by far the hardest thing to do. As I said, once the problem is explained, the solutions oftentimes are pretty obvious. But the problem space, explaining it, that's hard.
Yeah. Well, and explaining the problem to somebody who's never experienced it may be even harder than defining the problem originally when you're in the middle of it.
That's right. There's something special about experiencing the problem, right? Once you experience the problem, you have kind of a much more of a visceral reaction to it, and much more of like, yes, I get it. I've lived through this, versus like if it's just a theoretical thing, like, oh yeah, I can see how this could be a problem, but like, whatever.
Yeah.
Didn't run into it.
That. Well, in a longer form, like a workshop, you might be able to push them into experiencing the problem in some way.
Yes, but even creating that situation can be troublesome. I kind of did a post, like I was trying to explain this on Twitter the other day. I did a post and I said, hey, imagine you want to have a lazy loading of the component, right? So I kind of made a very, very simplistic application, a counter that was broken into 3 components, right? You would never do a counter this way, but like I intentionally did it in 3 components just so I have something to talk about, right? And I said, assume that this is too big and you need to break it into pieces. Assume you now need to do lazy loading, right? And then let me take you through the steps you might do to, do the lazy loading. And then hopefully in the process, I'm going to show you just like, A, how crazy difficult this is, and B, how the outcome you get is actually not the outcome you thought you were going to get. I tried. It was a good post. It went well. But like, it's hard. It's really, really hard to kind of explain that because on some level, you're asking the reader to just take your word or take your experience for granted, right? And humans are very skeptical. Like, yeah, I don't believe you, kind of a thing, right?
Yeah. Yeah. Cool. Well, awesome. I think we've hit all of the questions that I had pre-prepared. Thinking back through all the different things that we have talked about today, are there any topics that you feel like we have missed or should go deeper on?
I always talk about this, and I think this is particularly relevant to this discussion. There's this awesome book called Thinking Fast and Slow. I don't know if you read it or not.
Yes. Yes.
But
it's an excellent book.
You need to read this book. Like, to me, it's a owner's manual / instructions for your own brain, right? It is a collection of research. A lot of it is kind of mental exercises of like, pretend that you found $10. How would you like to spend it? Versus pretend you lost $10. How would you like to regain it, right? Like, you realize that those 2 scenarios are essentially the same and therefore you should behave the same way. And yet you realize very quickly, like, no, humans do not behave the same way in both those 2 scenarios, right? And there's basically a huge collection of these different examples of like what you can set up and how we will come to a completely different conclusion, even though we should come to the same exact conclusion. And the whole point of this book is to kind of show you how your brain lies to you, right? And I find this super interesting because, a brain is in a very good position to lie to you because it is you, right? And so it can delude you into all kinds of things, right? My favorite example is, the way people pick doctors, right? They don't know how to decide whether this is a good doctor or a bad doctor because they have no qualification to make the decision, right? And so human brain doesn't know how to answer that question. And so it will secretly substitute a different question. It will say, I can answer, I don't know how to answer the question of is this person good or not, but I can answer a different question. Do I like this person or not? And that's a question I have an opinion on and I know how to answer, right? And so I will answer that question and I will substitute that answer to the original question. And this happens all the time and you don't even notice, right? Where the answers you get are for the wrong question. And this is basically a form of lying to yourself that kind of happens all the time. And so knowing these things and knowing how your brain tricks and being on a lookout for these things, I think is super, super useful. So I think it's one of my favorite books. Everybody should read it.
Yeah, no, I love that recommendation, but I think there is something to dig a little deeper here on too, because it's not only a guide to how your brain is illogical and irrational.
That's right. So
also everyone else's brain.
Once you know these tricks, right, then you kind of can recognize when people are doing that to you or unintentionally. Like, I'm not saying there's ill intent with people, but people make these not necessarily mistakes, but like these shortcuts, right? And it's important to be able to kind of look for them, etc. And it also is important to kind of realize like these shortcuts happen, which is why it matters for you to be likable with others, right? Because, they are going to be like, so is this Miško guy, is he smart or not? I don't know, but like, I do like him. He's fun, right? So I'm going to decide that he's smart. I mean, hey, I'll take it.
Yeah. Well, and what this also does because I feel like one of the challenges for a lot of engineers as they look at that cliff into it's about the team, it's about other people. is, in addition to the big challenge we talked about can I measure my day? Do I get that immediate feedback? The other thing is that it feels incomprehensible.
Yeah.
I'm used to dealing with machines that give me, error
Yes.
messages that were really confusing at one point, but I have learned how to decode them.
Yes.
Human beings have a whole different class
Yes.
of failure states.
It's even worse. It's even worse, right? Because a computer will always give you the same error given the same conditions. Humans do not. And so while with computers, it's like, oh, I have this theory. Let me try it. Oh yeah, that theory is true because I got the answer I expected. With humans, it is a very different thing. You could have the same set of preconditions and run the experiment and you get completely different answers, right? And so at some point you're like, it feels like this is what's going on. And at least for me, this is really, really hard. Like, I know that a lot of other people tend to jump to these conclusions like, oh, I think what's going on is this. And I'm looking at it and go like, yeah, you're not wrong. That's definitely consistent with what you're saying. But I can also imagine this thing going on or that thing going on. And like, I think the more of a creative mind you have, the worse it gets. Because you go like, there's going to be all these things going on. Like, which one is true?
Totally. Yeah. But the other piece, though, is that as much as we have inconsistencies, there are also some consistencies.
Yeah.
And there are some ways that you can use, thinking fast and slow is great. And I love the metaphor of it's a user manual for your brain, right? Like there are patterns that you can learn that while they may not be 100% reproducible in the way they are in a computer, they're statistically reproducible.
Yes.
They will happen with some frequency. And so these skills, while they are less mechanistically learnable, they are learnable. And there are patterns that you can adapt and you can recognize and you can kind of move forward. All right.
Yeah, I think
that's
the
it for
hardest
this Human Skills
thing
interview.
for engineers
If you
to
enjoyed
get their
it, please
heads
consider
around,
liking this video and subscribing to this
certainly
channel.
at one
You can
point
also
was thinking the
subscribe to
same
the Human
exact
Skills
way,
newsletter.
is that
which there's
this
a link
idea
to
that
right
the
down
world
below to get
could be
notified
black
of
and
interviews
white.
like this
Like,
as
there
they
is
come out.
exactly
Take care,
the
y'all.
right
This
and
is
the
K
wrong
Ball
answer,
signing
right?
out.
And there certainly are many things that are clearly right or wrong. But there is a whole different category of kind of problems where the answers are more statistical distributions rather than right or wrong, right? And even the thing that you could argue is wrong statistically could have a small probability of an outcome, and so it's a very different mental model, right? And it's unnerving, and I think a lot of engineers don't like that because the computers are predictable. This isn't, and I think this is the thing that people struggle with. And the hardest thing I think out of it all is just people, and especially engineers, do not appreciate the importance of just being warm and fuzzy to others, right? That is so important with humans. And yet we fail on this particular thing as engineers over and over again.